If you add 1 drop of a strong acid to pure water, it will dramatically change the pH of that water, and this might be a good question for a quiz. But if you add 1 drop of strong acid to a buffer solution, the buffer solution will keep the pH from changing dramatically. The pH will either not change at all or just wiggle a little bit. And so a buffer solution is a solution that resists a change in pH upon addition of an acid or a base. Now, how does it do that? It does that by having as components a conjugate acid-base pair. If I have a solution that has both the conjugate acid and the conjugate base in it, then I have a buffer system. These have to be weak acids and bases. They can't be strong. For example, if I take some acetic acid and I add to it the salt sodium acetate. Sodium acetate is a salt, which means the first thing it's going to do is it's going to break up into the ions. It's going to dissociate to give me the sodium ion and the acetate ion. The sodium ion is neutral, so I can ignore it. And so I'm looking at a solution that has acetic acid and the acetate ion. This is a weak acid and its conjugate base. If I have a solution with both of these present, then I'm looking at a solution with this equilibrium reaction. Now, I have written the equilibrium reaction for the weak acid. I could have written the equilibrium reaction for the weak base, and it would demonstrate exactly the same thing. In this case, this reaction is in equilibrium in my beaker, and I do have some quantity of acetic acid, and I have some quantity of the acetate ion. Both of these are present. If I just put acetic acid in the beaker, there would be a very, very small amount of the acetate ion. If I just put the acetate ion in a beaker, for example, in the context of putting sodium acetate in the beaker, there would be a very, very small amount of acetic acid as that equilibrium established. But if I put both of them in the beaker, I have appreciable quantities of both of these. That means upon addition of a strong acid or a strong base, I have things that will react with them. For example, if I add an acid, a strong acid, let's say I add some HCl to this equilibrium reaction. Le Chatelier's principle says if you have a system at equilibrium and you stress it, the reaction will shift to relieve the stress. If I add an acid, that will have the effect of removing some of my acetate ion because my acetate ion is a weak base. An acid reacts with a base, especially a strong acid, and so some of my acetate ion will be removed and the equilibrium will shift back to the right to replace some of the weak base that was removed, in which case the equilibrium reestablishes itself and the amount of H plus that is present, so the pH of this solution, will remain approximately the same. There are limits to this. If I add lots and lots and lots of acid, at some point the buffer system will fail because it'll just be too much. But upon addition of a small amount of acid, there's absolutely no reason why this system couldn't handle it. Upon addition of a base, the base will have the effect of reacting with some of the acetic acid because the acetic acid is a weak acid. So if I add a base, a small amount of base, it's going to remove some of the acid that is present in my equilibrium, which will have the effect of shifting the reaction to the left, and the equilibrium will be reestablished. The pH of the solution will remain relatively constant. That would not be possible if I did not have both of these species present, because then there wouldn't be an appreciable amount on either side of the equilibrium reaction to do the shifting with. Alright, if I want to calculate the pH of a buffer system, the buffer system will be mentioned. There will be some amount of my weak acid and its conjugate base, or weak base and its conjugate acid. I will work the problem exactly the same way that I work the problem if I only had the weak acid or I only had the weak base. It's just that in my ice table I would have initial amounts of both species. So all it will change is what I put in my ice table for the initial amount. I won't have zero products. I will actually have numerical values to put for both, in this case, the acetic acid and the acetate ion. And we'll practice some of those in class.